All right, in this video, we are going to be factoring. We're going to start our factoring module. And factoring is really important. It's a skill that you're going to need all throughout geometry and especially Algebra 2. So it's really important that we lay a really strong foundation and that you understand what's happening and why we're doing it and how we do it. So our sub-objectives with this are to be able to find the GCF, or the greatest common factor, of a set of numbers, of a set of variables, and then to be able to divide algebraic expressions, and I'm going to walk you through that. You are able to make a leading coefficient positive, and then understand and explain the connection between factoring and using the distributive property. So we just finished up multiplying polynomials where we distributed things out. Now, and we put it together. Now the process of factoring is to break it apart. And so we're going to get back to that original form. So by the end of this lesson, you should be able to take these four expressions that are put together and break them apart into pieces that could be multiplied together. We're basically undoing that multiplication. So we're just going to do a quick review. These are pieces that are broken apart, and I want you to put them back together. So go ahead and simplify these three problems. So I see that I have a monomial being multiplied by a polynomial. So to get rid of those parentheses and to simplify, we're going to distribute and combine any like terms. So go ahead and do these three problems on your own. All right, so the first one, hopefully you were able to get negative 12x squared plus 9x minus 3. For the second one, hopefully you were able to get negative 32x to the 7th plus 16x to the 4th minus 8x to the 3rd. And hopefully the last one didn't throw you off. It's the same process. We just had two variables. So you should have gotten negative 20x to the 3rd, y to the 3rd, minus 12x to the 2nd, y to the 3rd. And minus 48x y to the 3rd. And so each one of these are different variables. Even though they all have y to the 3rds, they only can be combined if their variables look the exact same. So none of them have the same x's and y's. So when I think about the process of distributing, I want you to, in your own words, what does distributing mean to you? So we're going to go with this idea of distributing is multiplying all terms by a common factor. So when I look at each one of these terms, they all got multiplied by 4xy squared. Each one of these got multiplied by 8x to the 3rd, and each one of these got multiplied by a negative 3. So all of these three terms have a negative 3 in common. And these three terms, when I multiplied it out, all had an 8x to the 3rd in common. And each one of these had a 4xy squared in common. So I want you to keep that mindset as we move into the factoring piece that we're about to attempt. All right, so factoring is going to be the process of undoing distribution. So just like multiplication undoes division, addition undoes subtraction, factoring is undoing distribution. So keeping in mind that distribution is taking a common factor and multiplying it by each term in the polynomial. Now we're going to kind of work backwards. So if I gave you 8x to the 3rd minus 32x plus 24, and I wanted you to factor it, what do you think we would do? And my hint is this: 2 times 3 equals 6, and 6 divided by 3 equals 2. So this undid what happened here. So what do you think we would do if we were going to factor and it was the undoing of distribution? So we're going to come back to that, but I'm going to give you a little bit of information before that. So the GCF, hopefully you remember this from your elementary school years, but the GCF is the greatest or largest factor that a set of numbers have in common. So it's the largest number, greatest factor that a set of numbers have in common. And remember, factor are numbers that can be multiplied together to get that value. So a factor is never going to be larger than a value, a number that we're looking for. So if I were looking for the GCF of 6, 24, and 28, so the first thing I'm going to do is I'm going to list out the factors. So 6 has 1, 2 can go into it, 3 can go into it, 4 cannot, 5 cannot, but 6 can. So 24, 1 can go into it, 2 can go into it, 3 can go into it, 4 can, 5 cannot, 6 can, 7 cannot, 8 can, 9 cannot, 10 cannot, 11, 12 can, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 cannot, but 24 can. And so we always match them up. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So I have all of my factors. All right, and then I'm going to list the factors of 28. So 1 can, 2 can, 3 cannot, but 4 can, 5, 6, no, 7. So now we're making our way back because 4 times 7 is 28. So 2 times 14 and 1 times 28. So those are the factors of 28. So when I look at what they have in common, they all share a 1, they all share a 2, they don't all share a 3, they don't all share a 4, and they don't all share a 6. And 6 is the largest factor of 6, so I can't pay any attention to any of the other factors because it's the greatest common. It's the one that they all have in common. So the GCF of 6, 24, and 28 is going to be 2. That is the largest factor that they all have in common. All right, so let's go ahead and list out the factors of 12, 40, and 100 and see if we can identify the GCF. So go ahead and pause the video and see how many factors of 12, 40, and 100 you can find. All right, so hopefully for 12, you got 1, 2, 3, 4, 6, and 12. And for 40, you got 1, 2, 4, 5, 8, 10, 20, 40. And 100, 1, 2, 4, 5, 10, 20, 25, 50, and 100. So when I think about the greatest common, they all share a 1, they all share a 2, they don't all have a 3, but they do all have a 4. They don't all have a 6, and they don't all have an 8, and they don't all have a 12, and that's as high as I go. So the GCF of 12, 40, 100 is going to be 4. All right, go ahead and try the last one on your own. See if you can find the greatest common factor, and don't be fooled. All right, so hopefully you weren't tricked, but the greatest common factor that they all have is just 1. They don't share any other factor. So any 2 numbers or more will always have at least 1 in common. So keep that in mind as we move through this lesson and the next few lessons. All right, so our first sub-objective is finding the GCF of a number, and we have done that. So next we're going to find the GCF of variables. So if you remember, we're going to have these 3 variables. So x to the 5th, I can actually write as x times x times x times x times x. Because if I have 5 x's and they're being multiplied together, I add their exponents. So it's like x to the first, so there's 5 x's. So x to the 8th is going to be 8 x's being multiplied together. 2, 3, 4, 5, 6, 7, 8. And then x to the 9th is going to be 9 x's. So when I think about the greatest common factor, when we were looking at it before, it was the largest number that went into both of those, or what was the most they had in common. So when I look at it, they all have 2, 3, 4, they all have 5 x's. So the GCF of x to the 5th, x to the 8th, and x to the 9th is x to the 5th. That is the most amount of x's that they have in common. If you notice 8th and 9th, they have 3 more in common, but x to the 5th does not. So it's going to be x to the 5th is the GCF of those 3 variable expressions. All right, so go ahead and let's think about x to the 3rd, x to the 2nd, and x. So x to the 3rd is x times x times x. X to the 2nd is x times x, and x is just x. There's only one x. So the GCF of x to the 3rd, x to the 2nd, and x is going to be just x. That's the most amount of x's that they have in common is x to the 1st. All right, so go ahead and pause the video, and I'd like you to try finding the GCF of x to the 10th, x to the 4th, and x to the 3rd. All right, so hopefully you were able to find that x to the 3rd is the GCF of x to the 10th, x to the 4th, and x to the 3rd. And one thing I hope that you noticed when we're finding the GCF of variables is that the least amount of variables, the smallest degree or power, became my GCF. So if you notice, the smallest amount of variables became my GCF. So if you're looking for a quick way, go ahead and look at all your variables and find the least amount, and that will be your GCF. All right, so we found the GCF of a number, and now we found the GCF of a variable, so now we're going to put that together. So if I had 36x to the 5th, 12x to the 3rd, and 60x to the 2nd, and I were asked to find the GCF of that, I'm going to find the GCF of the coefficients. So I'm going to list out all the factors of 36, all the factors of 12, and all the factors of 60. So go ahead and look at the factors of 36, 12, and 60. And then I'm going to go ahead and list out the factors of x to the 5th, x to the 3rd, and x to the 2nd. So x to the 5th. And then it's 12x to the 3rd and 60x to the 2nd. So I'm going to go ahead and look at them separately. I'm going to find the greatest common factor of the numbers. So they all share a 1, they share a 2, they share a 3, they share a 4, they share a 6, and they share a 12. And since 12 is my smallest number, there's not going to be any factors greater than that. So 12 is going to be my GCF of the coefficients, and they all share 2 x's. So my GCF of 36x to the 5th, 12x to the 3rd, and 60x to the 2nd is 12x to the 2nd. That is the greatest common factor that all three of those numbers share. All right, so go ahead and I'd like you to pause the video, and I want you to try the remaining 3 examples on your own. All right, so for the second example, 2x was the largest GCF that they have in common, and hopefully the last two didn't trick you. 3 is the greatest common factor of those because 12 does not have an x, so they cannot share any x's if one of the terms does not have a variable. And then 1 is actually the GCF of the last 3 numbers. They don't share any variables, and the largest factor that they all have in common is 1. All right, so when I'm factoring out a GCF, these are the questions that I'm going to ask myself. So just like we did, what's the GCF of the coefficients? What's the GCF of the variables? Is the leading coefficient positive? And then when I divide out the GCF from each term, what remains? So we're going to use those questions to think through this process. All right, so let's go ahead and get started. So the first question I always ask myself is, what is the GCF of the coefficients? So when I look at the coefficients, I have a 6, I have an 8, and I have a 16. So when I list out the factors of 6, so 1, 2, 3, and 6, 8, 1, 2, 4, and 8, and 16, 1, 2, 4, 8, and 16, the greatest number that they have in common is 2. So then I look at the variables. What is the greatest number of variables that they have in common? So x to the 5th, x to the 2nd, and x leaves me with just one x that they all share. So the GCF of the variables is an x. And then is the leading coefficient positive? We always want that first number to be positive, and since it is not, the leading coefficient is negative, we are going to take out a GCF of negative 2x. So we get the GCF from the coefficients, the variables, and then we always look at that first coefficient, and if it's negative, we're going to take out a negative so that it will be positive, because a negative divided by a negative is positive. All right? So what I'm going to do, just like distribution was taking a common factor and multiplying each piece by it, we're now going to take our common factor and we're going to divide it out, because we're trying to get back to that original form. So with this, I am going to divide each term by the GCF. All right, so when I'm dividing by the GCF, what I took out goes out front, and then what remains is what goes in the parentheses. So negative 6 divided by negative 2 is 3. And then if I have 5 x's and I take 1 and put it out front, I have 4 x's left inside. And I can always double check because negative 2x times 3x to the 4th gives me negative 6x to the 5th. So I'm just taking it and putting it in that alternative form. All right, so 8 divided by negative 2 is negative 4. And if I have 2 x's and I take one and put it out front, then I'm left with 1 x inside. And I can double check, negative 2x times negative 4x is positive 8x squared. And then I take 16 and I divide it by negative 2, and that gives me negative 8. And if I have an x, just one x, and I take an x and put it out front, then I'm left with no x's inside, and that is my answer. So one way to check that I've taken out the largest variable is that my last term should always be a constant, because if there is another variable, if it's left with a variable, then that means I can take more out. So the last term should always be a constant. All right, so go ahead and look that over, and I want you to identify any questions that you have. What are things that make sense to you right now? What were the steps that I did? But go ahead and just kind of analyze this problem. All right, so now I have 15n to the third plus 6n squared minus 30n. So the first question is always, what is the GCF of the coefficients? So when I think about 15, 6, and 30, my GCF is 3. What is the GCF of the variables? So I have 3 n's, 2 n's, and 1 n. So the most that they have in common is an n. And then is the leading coefficient positive? Yes, it is. So I don't need to worry about that. So my GCF is just 3n. So I'm going to divide out 3n from each term, because that is the common factor that was originally multiplied or distributed into the original trinomial. So what I take out goes on the outside, and so then I divide it out. So 15 divided by 3 is 5. If I have 3 n's and I put 1 on the outside, that leaves me with 2 n's. And then if I have positive 6 divided by 3, I have 2. I have 2 n's. I put 1 on the outside, so I'm left with 1 on the inside. And then negative 30 divided by 3 is negative 10. And I had 1 n, and I put it on the outside, so that is my final answer. And I can always double check it by distributing, because factoring just undoes distribution. So 3n times 5n squared is 15n to the third. 3n times 2n is 6n squared, and 3n times negative 10 is negative 30n. So I know I've done it correctly. All right, so what I'd like you to do is I'd like you to answer the first 3 questions and see if you can determine the GCF of this polynomial. All right, so hopefully you're able to see that 10 is the greatest number that 60, 30, and 50 have in common, and that they all share just 1k, and the leading coefficient is not positive, so the GCF that we're going to take out is negative 10k. So go ahead and pause the video and see if you can continue factoring. All right, so hopefully when you divided out that greatest common factor, you ended up with negative 10k, and then multiplied by the polynomial 6k to the third minus 6k squared plus 3k minus 5. So if you didn't get that, go ahead and look over and see if you can identify where those numbers came from. If not, make sure you write a question, and we'll talk about it in your CSG. All right, let's go ahead and try this one. Again, I'd like you to try the first 3 questions on your own and see if you can identify the GCF of this trinomial. All right, I hope you weren't tricked, but the GCF of the coefficients is just 1, so I can't take any number out, but they do all share 2 r's, and the leading coefficient is already positive, so I don't have to worry about that. So my GCF is going to be an r squared. That's it. There's technically a 1 in front of it, but we're not going to put that in there. All right, so go ahead and pause the video and finish factoring. All right, so hopefully once you took that r squared out, you were left with 9r squared minus 8r minus 3. And remember, I can always distribute it back out to see if I factored it correctly. All right, I'd like you to pause the video, and I want you to try this one all on your own. Factor it completely. All right, so hopefully you were able to identify that the only thing that they had in common was a 7. They did not share a variable. And the leading coefficient is not positive, so I need that to be a negative 7 that I take out. And when I do, I'm left with 5x plus 2. All right, so on this one, I want you to pay close attention. It looks pretty straightforward, but this question right here, make sure you pay attention to which one is the leading coefficient. So go ahead and pause the video and factor this one. All right, so the first thing that I noticed is it wasn't in standard form, so I rewrote it with the largest degree out front. So 18x to the fourth plus 20x to the third plus 20x squared plus 4x. Then I looked at what is the GCF of the coefficients, and it's 2. What's the GCF of the variables? It's x. And is the leading coefficient positive? Yes, it is. And so this was meant to trick you. This was still positive as well, but that's not actually the leading coefficient, this 18x to the fourth, because it's always the highest degree. So when I factored that out, I ended up with 2x times the quantity, 9x to the third, plus 10x squared, plus 10x plus 2. All right, go ahead and pause the video, and I want you to try the remaining examples on your own. All right, go ahead and look it over and see what you got right. Write down any questions that you have or anything, be sure to statements that you noticed. All right, go ahead and check your answer and see how you did. All right, so on example 9, I want to show you what some of you might be doing because I did this at first, and I want to show you how you can fix it. So when I looked at it, the largest GCF that I noticed immediately was 3. So I took a 3x to the third out, and when I took that out, I was left with 6x to the fifth plus 10x minus 4. Well, what I noticed is that those still have a GCF. So that told me I didn't take out the largest number before. So then I just said, okay, well, they all have a 2 in common, so I'll take a 2 out. And so I put the 2 out here, and I multiplied it because I'm distributing, or I'm taking it out, so it's going to end up being multiplied by the original GCF that I took out. So 2 times 3x to the third gave me 6x to the third, which if I had noticed right off the bat, I could have taken a 6x to the third out at the beginning. So if you happen to not take the largest GCF out, always check and see, is there anything else I can take out? And then you just put it out front and multiply it, and you'll be fine. All right, and this last one, you should have gotten negative 7m times the quantity of m minus 8. All right, it's really important that you understand the connection between factoring and distribution. So we spent the beginning of this module talking about distribution when we're multiplying polynomials, and now we're moving into factoring. So go ahead and just reflect on how are they connected. All right, guys, we're done. So go ahead and in your notes, I want you to look over what you understand, make yourself a list of steps, be sure to statements, so be sure to look for the negative coefficient at the front, or what are the different things as you were going through this lesson that you were struggling with or that you were forgetting. And then any questions that you still have, make sure you write those down.